In this lesson, we will investigate solving problems involving two unknowns. We're going to use the methods of solving systems of equations to assist us with finding these solutions. First, let's look at some applications involving cost. At a movie theater, a couple buys one large popcorn and two drinks for $5.75. A group of teenagers buys two large popcorns and 5 drinks for $13. Find the cost of one large popcorn and the cost of one drink. So we need to set up a system of equations here. And in the last sentence it says find the cost of one large popcorn, so I can let that be X, and the cost of one drink, so I can let that be Y. So X is the cost of a popcorn, Y is the cost of a drink. Now we need to set up two equations. So when you have two variables, you're going to have two equations. Let's reread the first sentence. So the first sentence says they buy one large popcorn, so 1x, and two drinks for $5.75. So my 2 goes with the letter Y since Y is drinks. Now my cost goes on the other side. So let's write that equation here. X plus 2Y equals 5.75. The second sentence will give us the second equation. A group of teenagers buys two large popcorns, so 2x, and 5 drinks, so 5y, for $13, so equals 13. So let's write that equation. 2x plus 5y equals 13.00. Now I'm going to solve the system of equations using an appropriate method. Now what's a nice method here is to take the first equation and get that letter x by itself. It just really makes the end result a lot easier. You can also solve these equations by elimination where you add them together and try to cancel something out. So I'm going to instead look for a letter alone. I'm going to get x alone. So let's rewrite that. X equals, I need to move the y to the other side and subtract it. So I have 5.75 minus 2y. I'm going to kind of circle that funny because I'm going to come back to that equation towards the end. Now what I need to do is underline x, put parentheses around the 5.75 minus 2y, and go in the second equation. Underline x and put parentheses around it, and you're going to replace it with the 5.75 minus 2y. So let's write that equation. Instead of 2 times x, I get 2 times 5.75 minus 2y. Copy the rest of it down. Plus 5y equals 13.00. Let's clear parentheses. So 2 times 5.75 is 11.5 minus 2 times 2y is 4y. And then copy down plus 5y equals 13. Now we need to add the y's together. So 11.5 and negative 4y plus 5y, positive 1y, equals 13. Subtract 11.5 from both sides to get y alone. So y equals 13 minus 11.5, which is 1.5. So that's in cost. So y, the cost of the drinks, is $1.50. So now that I know one answer, you go back to the beginning and you go back to this equation where we wrote x equals. So x is 5.75 minus 2 times my answer y, which is 1.5. So type that expression in your calculator and you'll get x is 2.75, or $2.75. So the cost of a popcorn is $2.75 and the cost of a drink is $1.50. Now let's look at another application involving two unknowns. This is going to involve principal and interest. Interest equals principal times rate times time. Capital P is the principal, that's your investment money. R is the annual interest rate as a decimal. And T is the time it's invested in years. In our example, Joanne has a total of $6,000 to deposit in 2 accounts. One account earns 3.5% simple interest. So we're told that the total amount of interest at the end of 1 year is $195. We want to find the amount that she deposited into each account. Well, let's figure out how to label and see how many variables we have. Now, the way that we're looking at the differences in the 2 accounts is it's a difference of interest earned. So I can let X be the 3.5% simple interest account, and Y can be the 2.5% simple interest account. So the X is going to be the amount of money invested in that account, and Y is the amount of money invested in the other account. When we have two variables, we need to have 2 equations. Let's look at the first sentence because that's going to give us our first equation. Joanne has a total of $6,000 to deposit in 2 accounts. So my first equation is going to be my total money equation. And it's just X dollars plus Y dollars equals $6,000 total. No interest, no percentages there, just total money added together is $6,000. Now my second equation is going to come from the second sentence. One account earns 3.5% simple interest, so that's going to be 3.5% with X. And the other earns 2.5% simple interest, so it's 2.5% with Y. So what does this one equal? Well, it says the total amount of interest is $195. So that's what my account is going to equal total. So the second equation is going to be set up where we have our interest rates. And so whenever you have a percent, you always change it to the decimal equivalent and you move 2 places to the left. So 3.5% is 0.035, and you always want to multiply it by your letter. So we're going to have 0.035x plus 0.025y equals 195. So now that we've got our 2 equations set up, I'm going to take my first equation and I'm just going to get x alone. So I'm going to use the substitution method. So instead of x plus y equals 6,000, I get x equals 6,000 minus y. So we move the y over and subtract it to the other side. So now I can go in the second equation and I can underline my x, and I'm going to replace x with 6,000 minus y. So I get 0.035 times 6,000 minus y, and then copy the rest down, plus 0.025y equals 195. Clear parentheses. So 0.035 times 6,000 is 210 minus 0.035y plus 0.025y equals 195. Let's add those y's together. So 210 and negative 0.035 plus 0.025 is negative 0.01y equals 195. Now we want to subtract 210 from both sides to get the y alone. So negative 0.01y equals 195 minus 210, which is negative 15. Divide both sides by negative 0.01. So negative 15 divided by negative 0.01 is equal to 1,500. So we invested $1,500 in the account that was at an interest rate of 2.5%. To find the amount of money that we invested at the other percentage rate, we just need to go back at the beginning and plug into our x equals equation. X equals 6,000 minus y. So 6,000 minus 1,500 gives us x equals $4,500. Let's look at another interest rate question. Blake borrowed a total of $4,000 in 2 different loans. One loan charges 2% simple interest and the other charges 5% simple interest. If he is charged $155 in interest after 1 year, find the amount borrowed at each rate. So the way that they are labeling these 2 different accounts again is through percentages. So we have X can be the amount loaned at 2% interest, and Y can be the amount loaned at the 5%. So you have the 2 different percentages, one is X, one is Y. So my first equation is going to be again my total that I have in the money. So total money. Let's look at the first sentence to get that first equation. Blake borrowed a total of $4,000 in 2 different loans. So this is just regular X plus regular Y equals $4,000 total. Our second equation is going to be the one with the percents. So you take your percent 5 and 2, so let's take the 2. 2% is 0.02, so put it with X, 0.02X plus 5% is 0.05, put that with Y, and let that equal the total amount charged in interest, equal to 155. So to solve the system of equations, we can go back and we can take the first equation and we can get X alone. So X equals 4,000 minus Y. So we just move the Y after the 4,000 and we change it to minus. Now I'm going to underline X in the second equation and plug in. So I get 0.02 times 4,000 minus Y plus 0.05Y equals 155. Let's clear parentheses next. So 0.02 times 4,000 is equal to 80 minus 0.02Y plus 0.05Y equals 155. So then we have 80 and negative 0.02 plus 0.05Y. We're going to add those coefficients, and that equals positive 0.03Y equals 155. Subtract 80 from both sides. 0.03Y equals 155 minus 80 is 75. And so Y equals 75 divided by 0.03, which is 2,500. So we were loaned $2,500 at the 5% simple interest. So to figure out how much money was loaned at the 2% simple interest, you go back to your X equals equation. X equals 4,000 minus Y. So 4,000 minus 2,500 gives us X equals $1,500. So Blake borrowed $1,500 at 2% and $2,500 at 5%. Another type of application problem we need to know is one that involves mixtures. So a common mixture problem involves mixing different solutions, then we want to dilute their mixture rate. So here's an example. A 10% alcohol solution is mixed with a 40% alcohol solution to produce 30 liters of a 20% alcohol solution. We want to find the number of liters of 10% solution and the number of liters of 40% solution required for the mixture. Okay, so I have 2 different bottles here that I'm mixing together to achieve my mixture here. So I have X liters, I have Y liters, and then I have X plus Y total liters. Now my percentages are I have a 10% solution that I'm mixing with a 40% solution to produce 30 liters total of 20% solution. So use this type of a diagram to help you organize everything with appropriate percentages. So since we have two variables, we're going to have two equations. My first equation is going to be my total liters equation, just like I did with the money that I was investing. It's x plus y, so x liters plus y liters equals 30 liters total. My second equation is going to be the one with the percents, just like I had with the money questions. So I have 0.10x plus 0.40y equals 0.20. And then this here is a little different because you need to make sure that you take into account that you're mixing together your x and your y. So we have to have over here our total liters, which is 30. Okay, so now let's go ahead and get x alone in that first equation. So x equals 30 minus y. And so then I'm going to underline x, and I'm going to go in the second equation and underline x, and I'm going to substitute the 30 minus y expression. So I have 0.10 times 30 minus y plus 0.40y equals, and let's solve this here, 0.20 times 30. So 0.20 times 30 is equal to 6. Now I would need to clear parentheses here. So this gives me 0.10 times 30 is 3 minus 0.10y plus 0.4y equals 6. So now I need to add like terms. So negative 0.1y plus 0.4y, that becomes positive 0.3y equals 6. Subtract 3 from both sides to get y alone. So 0.3y equals 6 minus 3, which is 3. So y is 3 divided by 0.3, which equals 10. So y is 10 liters. So now I go back and I look for my x equals equation. X equals 30 minus y. So x equals 30 minus 10. So x is 20 liters. So we mix 20 liters of 10% solution with 10 liters of 40% solution to produce 30 total liters of a 20% alcohol solution. So let's try this procedure again. How many ounces of 20% and 35% acid solution should be mixed together to obtain 15 ounces of a 30% acid solution? So again, I have a mixture and I have two different solutions that I'm mixing up to produce my final mixture. So I have x ounces plus y ounces is equal to my total x plus y ounces, and I have 0.2 or 20%, 0.35 or 35%, and I want to mix that together to obtain 15 ounces total of a 30%, so 0.3. So my first equation is going to be my total ounces. So it's just regular x plus regular y equals total ounces 15. My second equation is where I'm going to put all the percents in. So you just look at this top equation, but you just put your percents with them. So 0.2x plus 0.35y equals 0.3 times 15. Take the top equation and get x alone. So x equals 15 minus y. Underline x in both equations and you're going to substitute in. So 0.2 times 15 minus y plus 0.35y equals 0.3 times 15, which is 4.5. Clear parentheses. So 0.2 times 15 is 3, minus 0.2 times y is 0.2y, plus 0.35y equals 4.5. Now we need to add up the like terms. So I have a negative 0.2 plus 0.35. That sum is equal to positive 3.3y. Subtract 3 from both sides to get y alone. 3.3y equals 4.5 minus 3, or 1.5. So y equals 1.5 divided by 3.3, which is equal to, so this right here is going to give me a decimal, and you can definitely do a decimal. So 1.5 divided by 3.3, it's a 0.45 repeating, and when that's a repeating decimal like that, you know it can also be expressed as a fraction. So if you know how to convert to fractions in your calculator, you can do that. You could just also round it off if you want to, but this answer as a fraction is going to be equal to 5/11. So if you are one of my students in class, you can just ask me, how do I get that answer to work in my calculator, and I can send you a tip on that. So I have 5/11 ounces that I'm mixing up. So now let's go and find out what the other amount is. So I want to look for my x equals equation. X is 15 minus 5/11, so you could do 15 minus 0.45. So x is equal to 1/60/11, or 14.5454 ounces. So the last thing that we want to look at are just some miscellaneous mixture applications. At the start of a business each day, Peterson's Bakery in St. Augustine has twice the number of $1 bills as $5 bills in the cash register. If the register holds a total of $175 in $1 and $5 bills at the start of the day, how many of each type of bills does it end up having? Okay, so the question at the end will help you set up the variables. It says, how many of each type of bills does it have? And so we have $1 bills, that can be X, $5 bills can be Y. So my first equation is I can look for anything in my sentences that relates these two variables together. For instance, in the first sentence, it says that we have twice the number of $1 bills, X, as $5 bills. So I have twice as many $1 bills as I have $5 bills. So my X, the number that I have for X, is going to be 2 times the number of $5 bills, so 2 times the Y. So that's called a comparison equation. So when you see words like twice or 3 times as many, it's a comparison of the two variables. Okay, so when we have two variables, we must have two equations. So you need to reread carefully to see another comparison. It says in the other sentence that if the register holds a total of $175 in $1 and $5 bills, so that means that if I have X plus 5Y, and I'm doing the 5 times Y because the Y is $5 each. So I have $1 for each X, $5 for each Y, and that equals my total amount of money, which is $175. So this right here is my total money. The first one was my comparison. Now the first equation is already set up where X is equal to 2 times Y, so we can use substitution there. X is 2Y, so I'm going to underline X in the second equation and substitute. So I get 2Y plus 5Y equals 175, or 7Y equals 175. Divide both sides by 7, and Y equals 25. So now let's go and find out what X is. So X is 2 times Y. So 2 times 25 gives us 50. So there are 50 $1 bills in the register and 25 $5 bills in the register. In the 1971 to 1972 NBA basketball season, Kareem Abdul-Jabbar of the Milwaukee Bucks made 1,663 baskets. Some of the baskets were free throws worth 1 point each, and some were field goals worth 2 points each. The number of field goals he scored was 151 more than twice the number of free throws. So first let's focus on how many field goals did he make and how many free throws did he make. So we can let x equal the number of free throws that he shot, and y can equal the number of field goals. Now I have in the first sentence, it says that he made 1,663 total baskets. So x free throws plus y field goal shots equals 1,663 total shots that he made. So that's my first equation. Now for my second equation, I'm going to use this comparison equation down here. It says the number of field goals he scored was, so my field goals is the variable y. So y equals 151 more than twice the number of free throws. So that's going to be 151 plus 2 times 504. So y equals 151 plus 2 times 504. Okay, so that simplifies to y equals 1,159. Let's back that up a little bit here. So I think I put in some extra information that we didn't know yet. Okay, so let's go back and do that. So y equals 151 more than twice the number of free throws. So we don't know the number of free throws. That's our x. So we need the variable there. So y equals 151 plus 2x. Okay. Now in this one I know y equals, notice how I have the letter y alone. So I can substitute for y in the first equation. I'm going to put parentheses around that, and I'm going to put the 151 plus 2x up there. So that gives me x plus 151 plus 2x equals 1663. So if I add like terms, I have 3x plus 151 equals 1663. And I'm going to subtract 151 from both sides. So 1663 take away 151 is 1512. Divide both sides by 3 to get x equals 504. So if you look back at this, it says he made 504 free throws. How many field goals did he make? So I'm going to go back to the y equals equation and substitute my answer. So y equals 151 plus 2 times 504. So y is equal to 1159. So he made 1,159 field goals. So how many points did he score then? Well, the way the points work out are that the free throws are worth 1 point each and the field goals are worth 2 points each. So if he made 504 free throws, then he has 1 point times 504, so that's 504 points. And he shot 1,159 field goals, and field goals are 2 points each. So 2 points times 1,159 baskets gives us, let's do that. So 2 times 1159 gives us 2318 points. Okay, so the total points is going to be the sum of that, which is 2,822 total points. So if Kareem Abdul-Jabbar played 81 games during the season, what was the average number of points per game? So just take your total points and divide by the number of games. to get your average. So 34.8. So about 35 points per game. Okay, so we just have one more example that we're going to work through. Mary Lee's natural food store sells a combination of teas. The most popular is a mixture of tea that sells for $3 per pound with one that sells for $4 per pound. If she needs 40 pounds of tea that will sell for $3.65 a pound, how many pounds of each tea should she use? Okay, so I have a mixture of two different types of tea, and the way that they are giving us the differences here is that we have one that's $3 per pound, so that can be X. We have another that is $4 a pound, that can be Y pounds, and we need 40 total pounds, and we want to sell that for $3.65 a pound. Okay, so let's set up our two equations. First, we're going to do total pounds. So it's just like with the money, you do total cost. With the mixture, you do total pounds, total ounces, whatever you're mixing together. This is just regular X plus regular Y equals total pounds 40. Then in the second equation, if you have percentages, you're going to put that there. Here we have prices or costs, so we're going to put the prices in. And you can just look at this first equation and fill in with your prices. So 3x plus 4y equals 365 times 40. So now let's look at the first equation, and we need to get a letter alone. So I'm going to get x alone here. So x equals 40 minus y. Underline x in the second equation and substitute 40 minus y in for x. So let's rewrite that equation. 3 times 40 minus y plus 4y equals, and let's solve 3.65 times 40 and we get 146. Now distribute 3. And we get 120 minus 3y plus 4y equals 146. Negative 3y plus 4y is positive y. Subtract 120 from both sides to get y alone. So y equals 26. So we have 26 pounds of tea that cost $4 a pound. And to figure out how many pounds of the other, we go to our x equals equation. So x equals 40 minus y, or 40 minus 26. So x equals 14 pounds. So we're going to mix together 14 pounds of the $3 tea and 26 pounds of the $4 tea to get a resulting 40 pounds of tea that we can sell for $3.65.